Hello everyone, the headline of our lesson for today is domain and range of function. Definition. What is the domain? Is the set of all values of x where f of x is defined. X-axis is the set of domain, either whole x-axis or an interval of it. What is range? It is the set of all possible value of f of x. When we substitute x in the function, the value, the result, it is the value in the range. Graphically, the domain is either whole x-axis from negative infinity to positive infinity, or the part of x-axis that cover the function, that cover the graph of the function, if the graph has no cutting or jumping. For this example, the first needed is find the domain and range of f, domain and range of g. This is the function g, and this is the function f. The domain of f, as you see, it is started from -4, ended at 5 at this point, ended at 4 this point. The value of x here is -4, and the value of x here 4. Then the part of x-axis that cover this line is start from -4 up to 4. The line not contain any gap, any cutting, or any jumping. Then the domain of f equal to closed interval, since -4 lie in the line, -4 to 4 also close bracket, because 4 lying in the line. This is for domain. For the range, is either all y-axis, the value of f of x, all possible value of x, either all y-axis or a part that cover the line, the graph of the function. As you see, the graph start according to y from -3 up to 5. Then the range of f equal to closed bracket from -3 to 5. From -3 to 5. This is the value of f of x. From -4, this is the value of x. For the function g, the function, the graph started from -3, then the domain of g equal to from -3 to 3. The last point in the graph, according to x-axis, is 3. Then the domain is from -3 to 3. The range of g equal to, according to y-axis, the range start from -4. -4 is on the graph up to 4. From this part to this part. This part all is the range of the function, closed interval. That is how we find the domain and range for any function graphically. If we have a gap here, for example, if we have a gap here at -2, then the domain will be -3 to 3, -3 to 3, except -2 because I have a gap. But now we don't have a gap, then, and the function is continuous, then the domain of G is from -3 to 3. Needed to find x, verifying f of x equal to g of x. We solved like this question before. The point make f of x equal to g of x is the point of intersection of these two graphs. The point of intersection is -1, 0. We have only one intersection point between f of x and g of x. Its coordinate is -1, 0. Find f of -2. This is -2. This is f of -2. It is -1. F of -2 equal to -1. Find g of 3. This is 3. This is g of 3. It is -4. It is g of 3. It is -4. Estimate a solution of f of x equal to. What is the value of x make f of x equal to? This is f of x. This is f of x equal to. What value of x make f of x equal to? It is 1. Then f x equal 1 is the solution of f of x equal 2. Estimate the solution of f of x equal g of x equals 0. What is the value of x make g of x 0? It is the intersection point of the function g with x-axis. We have three intersection points: x equal -1, x equal 1, and this point x equal 2.3. How we can find mathematically domain range for different functions? We start with the constant function, y equal a number, any real number. The domain of this function is R, and the range is 1 point. It is the y-intercept here. If we have a function, for example, y equal -1, this is y equal -1, then the domain is R and the range is -1. For linear function, for any linear function, the domain is R and the range is also R. R, it is all real number from -infinity to +infinity. You should pay attention that the bracket from the side of -infinity and +infinity always be open, not closed. This is closed bracket and this is open bracket. This bracket means that this point not in the interval. As you see, this example, y equal x minus 2, it is linear function. Its domain R goes from the right side without bound, increasing without bound, we from the left side decreasing without bound to -infinity. Also range, it is increasing and from the right side and decreasing from the left side. So the quadratic function, its domain, all polynomial from degree 0 to degree n, all polynomial, its domain is all real number. But the range changed depended on the function. Quadratic function, its domain is R and its range depends on A. Its range depends on the coefficient A. If A greater than 0, then the domain will be close in bracket f of x mini up to +infinity. What is x mini? It is the value of x coordinate in the vertex. As you know, the graph of the quadratic function is always parabola, either open to the above or open to the down. Then the x coordinate in the vertex, it's x mini, and when a is positive, then the range will be from this point to infinity. If a less than 0, then when a is negative, then the range will be from negative infinity to f of x max. Also, f of x max is the x coordinate in the vertex. Here, for this function, the range is from negative infinity to this f of x max, the maximum value in the range. Example, find the domain of range of this function. The domain is R. For the range, either I'll solve this function by quadratic formula, or I rewrite it as complete square. Let me rewrite it as complete square, it's easier. I'll add and subtract the coefficient of x divided by 2 square, it is 1 over 4. Then I'll add 1 over 4 and subtract 1 over 4 to this function to make it complete square. Now, x power 2, x minus 1 over 4, 1 over 2 square, plus 3 minus 1 over 4, then it will be x minus 1 half over 2 plus 4, 12 minus 1, 11 over 4. Then the range will be, since the coefficient is positive, then it will be from 11 over 4 to positive infinity. Find the domain and range of this function, x power 2 minus 1 equals 0. The domain is R, and the range is, as you know, this function, its graph is like this. Then the range is from negative 1 to positive infinity. Example, find the domain and range of this function. The domain is R, and the range, as you see, this 1, 2, 3, this graph of this function is like this. Then the range is from negative infinity to 3. From negative infinity to 3. Example, find the domain and range of this function, x plus 4 all square. The domain is R, and the range, the graph of this function 1, 2, 3, 4, it's shifted to the left 4 units, and the vertex is here. Then the range is started from 0 to positive infinity. Find the domain and range of this function. Domain is R. The range, if I want to graph this function, x minus 2, this is x minus 2, negative 5, 1, 2, 3, 4, 5. This is the vertex of this function, then the range is from negative infinity to negative 5. Start from negative infinity to negative 5. Example, find the domain and range of this function. The domain is R and the range. If I want to find the range, the easy method is to graph this function, since we studied graph before too much. X plus 3, 1, 2, 3, shifted 3 unit to the plus 7, 1, 2, 3, 4, 5, 6, 7. Then this is the vertex here. The range is start from 7 to positive infinity. Cubic polynomial, the domain of a cubic polynomial, since it is polynomial, then the domain is R. The range of cubic polynomial is also R. It is not depending on the coefficient of the x with the maximum power. Example, since it is polynomial of degree 3, then the domain is R and the range is R. Also, this function, since it is polynomial of degree 3, then domain of f equal to range of f equal to all real number from negative infinity to positive infinity. Rational function. The domain of rational function is all real number except where those where the denominator is 0. I'll subtract from the real number all the values that make the denominator 0. For the range, it is more complicated, so we will discuss these two cases, the most common cases, these two cases, 1 and 2. If the rational function is a constant over linear function a over a x plus c, then the range is all real number except 0. Why all real number except 0? Let me explain it here. If I set y equal to a over ax plus c and solve this equation to find x, then a equal to axy plus cy. Then axy equal to a minus cy. Then x equal to a minus cy over a y. Here, the denominator, the value make the denominator 0 is y equals 0. Then y never been 0. So the range is R except 0. Because if y is 0, then x is undefined. That is. For the second case, if we have a linear function over a linear function, then the range is a r all linear except the coefficient of x here over the coefficient of x in the denominator, a over c. Why this? How we can find this? If we solve this equation, ax plus b over cx plus d to find x, then cxy plus yd equal to ax plus b. Set the term with x in one side, cxy minus ax equal to b minus yd. Then factorize by x, cy minus a equal to b minus yd. Then x equal to b minus yd over cy minus a. What is the value making the denominator 0? It is not in the range because making x undefined. cy minus a equals 0, give me cy equal a, give me y equal a over c. Then I subtract a over c from the range because this value make the denominator 0, and when the denominator 0, x is undefined. Now, depending on these two cases, find the domain and range of this function, 3 over 2 minus 2x minus 1. To find the value, make denominator 0. I set 2x minus 1 equals 0 and solve to find x. 2x equal 1, x equal 1 over 2. Then the domain is R except 1 over 2. This bracket is for set. It's not for interval. So R except 1/2 because 1/2 make the denominator 0. For the range, I'll apply this rule. This is R except 0 since I have a constant over linear function. Example, find the domain and range of this function. To find the domain, I set negative 3x minus 2 equals 0 and solve for x. 3x equal negative 2, x equal negative 2 over 3. Then the domain is R except negative 2 over 3. Or I can write it as negative infinity to positive infinity except 2 over 3. Or sometimes we write it like this. The range of this function, I'll apply this rule, number 2, then it is negative 5 over 3 or 5 or negative R except negative 5 over 3 or 5 over negative 3. Find the domain and range of these find only the domain of these functions. The domain is all real number except those make the denominator 0. So I'll solve this function to find x equals 0 by experiment x minus 2 minus 1. And then x equal 2, x equal 1. Then the domain is all real number except 1 and 2 because this value make the denominator 0. Find the domain of this function. X power 2 plus 4 equals 0, x power 2 equal negative 4, x equal negative positive square root negative 4, not a real number, then the domain is all real number since there is no point make the denominator 0. Number 5, square root functions. The domain is the solution of the inequality. If we want to find the domain of any square root function, standard square root function, like this, ax plus b, linear function under the root. This if we want to find the domain of this kind of functions, then we will solve the inequality ax plus b greater than or equal 0. The term under the root greater than or equal, I set it greater than or equal to 0 and solve to find the value of x. Then the domain will be from this value to infinity. The range separated to two case. If the root preceded by positive, then the range is from 0 to positive infinity. If the root preceded by negative, then the range is from negative infinity to 0. Let us solve example. Find the domain and range of this function. I set x minus 1 greater than or equal to 0 and solve it to find x. Move 1 to the other side, then the inequality will be x greater than or equal to 1. This I can rewrite it as 1 to positive infinity with 1, of course, since I have equal here. So this is the domain of this function. For the range, since I have positive here, then the range is from 0 to positive infinity, of course with 0. Since 1 is here, 1 is in the domain, 1 minus 1, 0, then the first value in the range is 0. Let us solve this equation. This function, find the domain. To find the domain, set x plus 3 greater than or equal to 0 and solve this inequality, x greater than or equal to negative 3, then the domain is negative 3 to positive infinity. This is the domain. For the range, since it is preceded by positive, then from 0 to positive infinity, it is the range of this function. Find the domain and range of this function, negative 2 square root 3x plus 1. Set 3x plus 1 greater than or equal 0, 3x greater than or equal negative 1, x greater than or equal negative 1 over 3, then the domain is negative 1 over 3 to positive infinity, open bracket from the side of infinity, close bracket from the side of negative 1 over 3. Since the root preceded by negative number, then the range is from negative infinity to 0. Example, find the domain and range of this function, f of x equal 1 over square root x. If the square root is in the denominator, then we solve the inequality. The term under the root only greater than 0, not equal. I cannot, if the root is in the denominator, I cannot write equal because 0 make the denominator 0 and f of x is undefined. Then I set x greater than 0. X greater than 0, it means 0 to positive infinity. This is the domain of this function. For the range, it is from 0 to positive infinity, since the constant here is positive. Find the domain and range of this function, x plus 4 greater than 0, only greater because it is in the denominator, x greater than negative 4, then negative 4 to positive infinity, it is the domain. The range is from 0 to positive infinity, since 5 is positive. Pay attention to this example, it is different. I have addition of two square roots. The first one, the domain of the first one is from 0 to positive infinity. Set x minus 1 greater than or equal 0, then x greater than or equal 1, then the domain of this square root is 1 to positive infinity. The domain of the function, all the function, is intersection between 0 to positive infinity with 1 to positive infinity. Then the intersection is, this is 0, this is 1, this is 0 to infinity, this is 1 to infinity. The intersection is from 1 to infinity to positive infinity. Hence intersection interval. The intersection interval, it is from 1 to positive infinity, and this interval is the domain of this function. Now, when I substitute 1 here in the first root, the function will be 1 plus square root 1 minus 1, or yes, 1 minus 1, 0, then the answer is 1. So the first point in the range is 1, 1 up to positive infinity. It is not from 0 to infinity. Another example, find the domain and range of this function, 1 minus square root 1 minus x. If I have a number subtracted by a root, or a root subtracted by a number, or a number plus the root, or a root plus a number, then how can I find this kind of function? For the domain, I'll follow the same steps. 1 minus x, set it greater than or equal 0, solve for x, 1 greater than or equal x, or x less than or equal 1, then the domain is 1 to negative 1, oh sorry, negative infinity to 1. Negative infinity to 1. For the range, this is the domain. The range of f, I substitute 1 in the function. 1 minus 1, it is 0. 1 minus 0, 1. Then the domain, the range is negative infinity to 1. Since the root preceded by negative, then the range is negative infinity to 1. Example, find the domain and range of this function. For the domain, follow the same steps. Set 3x minus 9 greater than or equal 0, then 3x greater than or equal to 9, then x greater or equal to 9 over 3, 3. Then the domain is 3 to positive infinity. This is the domain. For the range, since the root preceded by positive and added to 3, then substitute the first point in the domain of the function, 3 times 3, 9 minus 9, 0, 0 plus 3, 3. Then the first point in the range is 3 to positive infinity. Example, find the domain and range of this function. I have a rational function inside the root, and I want the root to be inside the root to be positive. How I get the positive from the inside root? Look, what is the value make x minus 1? 0, it is 1. What is the value make x minus x plus 1? 0, it is negative 1. So, when x greater than 1, the function x minus 1, it is the value positive or negative? It is positive. 2 minus 1, 1, it is positive. When x less than 1, the value of this root is negative. Now, for the denominator, when x greater than negative 1, the value is positive. When x less than negative 1, the values is negative. Then, where is the positive? Negative over negative, it is positive. Positive over positive, it is positive. Negative over negative, it is negative. Then the domain is negative infinity to negative 1, except negative 1, since negative 1 makes the denominator 0, union 1 to infinity with 1, because 1 plus 1, 2, it is not 0. The numerator, if it is 0, it is not, doesn't matter. Then this is the domain of this function. For the range, I must solve y equal square root x minus 1 over x plus 1 to find the value of y. Square root both sides, cross multiplication, solve this equation to find the value of x, y square x plus y square. Set the term with x in the same side, x minus y square x equal to y square plus 1 factorized by x, 1 minus y square equal to y square plus 1, then x equal to y square plus 1 over 1 minus y square. Difference of 2 square, 1 minus y, 1 plus y equal 1, y equal negative 1. Then the range will be 0 to infinity, except 1, since negative 1 is already not contained in the interval 0 to infinity.